Hello students, good morning. Uh, Today student we will study about the Kirchhoff's law and Wheatstone bridge. Remember students, this Kirchhoff's law and Wheatstone bridge both you have to study in the next chapter, that is in electric current or the current electricity. But to solve few question of capacitor, I'm teaching you this particular law, okay, that will help you a lot, and this will help you in next chapter also. Okay, it will be repeated. My dear students, today we are in lecture number 30 of chapter 2, unit electrostatics. My dear student, first we will start with the Kirchhoff's law. Okay, Kirchhoff's law. Kirchhoff has given two law. Remember, one, it was KCL, this is the very famous, and KVL. KCL, it means the Kirchhoff's charge law. KCL, it is charge law. Kirchhoff's charge law, based on conservation. Remember, conservation of energy. It is based on conservation of energy. And the second one, which is KVL, this is known as voltage law, Kirchhoff's voltage law. Okay, voltage law. And this voltage law is based on conservation of, sorry, this is based on conservation of charge, okay, the first conservation of charge, and this one is at conservation of energy. My dear student, this particular law, the first law, KCL, it is also known as the Kirchhoff's junction rule. Okay, in next chapter this will be considered the Kirchhoff's current law, okay, and junction law. And this KVL, this is also known as the Kirchhoff's loop law, Kirchhoff's mesh law, okay, voltage law. It has the many names, but these two are very important to solve the electronic circuit, problems of electronic circuit. We'll try to understand how this two law works in our course. Remember, so the first one, Kirchhoff's charge law. Actually, student, charge law gives you the concept, the net charge at any junction. Remember, net charge at any junction must be zero. Net charge at any junction must be zero. What does it mean? It means if you are having a circuit like this one, and the capacitors are connected, okay, suppose C1, C2, C3, here the potentials are V1, V2, V3, and this terminal at the potential, suppose V, and charge are moving. The charge, whether the charge will come to this capacitor or will go from this capacitor, totally depends on the potential difference. Suppose the charge is going Q1, charge is coming Q2, charge is also coming Q3. Remember, by I myself just giving you the charge, from where this charge is coming, it is not known. I am taking a simple section of a circuit to explain you this particular law, that is the charge law. This point, you can see this point is termed as the junction. That's why this is also called the junction law. Junction law. Okay, and what is the law, exact law? Law Q net must be equals to 0. Where? At V, at, suppose this point O, at O. In short, I'm writing here the O is nothing but the junction. So net charge at any junction must be equals to 0. In next chapter you will study the net current at any junction must be equals to 0. But to remember or to understand this particular law, remember one thing, that is the assumption only. If charge is going, that is outgoing charge, if you are taking as positive, then incoming charge, okay, that charge is incoming must be taken with the nature negative. If charge is going from this junction and you are taking as positive, then if any charge is coming to this junction must be taken as the negative. If you are taking this charge as negative, then this charge will be considered as positive. This is assumption only. Remember, again I'm telling you, this is only assumption. Okay, student, using that assumption, what you will write using this equation and this assumption, you will write from this particular junction, as we have taken the assumption outgoing charge will be taken the positive. It means at junction O you can write Q1, this is positive, minus Q2 minus Q3 will be how much? 0. It means Q1 is equals to Q2 plus Q3. This is an equation that will help you to solve the electronic circuit, my dear student. Another form of this particular law, that to write mathematically, you can write in another way. If you are not having the charge but you are having the capacitance and potential, then you can write this equation also. How you will write? So in terms of that potential and capacitance, Altair, we are writing here. So as we have to write the Q net 0, and we know that Q is equals to how much? It is C into V. Okay, if charge is going from this point in this direction, look at here, arrow is in this direction. If charge is going, of course this V will be at higher potential and this is low potential. If charge is coming to this point, it means V2 is high and V is low. Here V3 is high, V is low. Okay, so what will be the charge over here? Q1 can be written as C into V, and what is C? It is C1. So C1 and V, that is the potential difference. Potential V is greater because charge is going from here. So the V minus V1 plus, for this capacitor you can write C2, high potential, V2. So the V2 minus V plus C3, V3 minus V equals to how much? 0. Okay, my dear student. Now you are having another equation. Either you will use this equation or you can use this equation. Okay, which will be much effective? You can use that equation. So this is the Kirchhoff's charge law, my dear student. Now we are moving for the Kirchhoff's voltage law. I'm rubbing this one. Can you note down? Yes. Now Kirchhoff's voltage law. KVL. Okay, as I told you, this particular law is based on conservation of energy, potential energy. Now my dear student, in this particular law, Kirchhoff has given the concept, the total potential. Remember, total potential or voltage in a closed loop, must be equals to 0. Loop, it means the closed circuit. If you are moving from any point, then after moving entire circuit you reach to that point, then that network will be considered the closed circuit or the closed network. Okay, so according to this particular law, KVL, total voltage in a closed loop must be equals to 0. Okay, now what does it mean? That is the total voltage is 0. Try to understand by the simple circuit or the example. You are having a capacitor, it is connected by a battery. Okay, charge is moving, the capacitance C, the voltage of this battery is V. Now you have to move in this particular circuit while you are writing the equation. Okay, in your learning period you have to represent this circle that you are moving in this way. Okay, that's why if the circuit are very long or lengthy, you will have the knowledge, yes, I am moving in this particular direction, clockwise or anti-clockwise. Remember, if you are having the 5 loops in a circuit, then you can move clockwise, anti-clockwise, that is in 5 different way for the different circuit. It doesn't matter. Okay, now you have to write, look at here, from here to here there will be no loss of potential, but at this point the potential will drop. Now what is the potential? So potential is, as we know, that Q equals to CV, Q equals to CV, so V can be written as the Q by C. So the potential at this point will be Q by C. What will be the charge? Suppose Q, so the potential will be Q by C. This potential drop from which battery? This battery. It means this has been subtracted from this value. Now you are moving, and as you are moving in the circuit in this direction and you reach to the battery again, so the battery terminal, you can see this is negative and this is positive. You have to use this negative terminal and voltage V is equals to 0. You are moving from this point and again reach to this point, and this is 0. The equation is Q by C is equals to V. Now I'm sure that you have been stopped yourself at this point when I told you you have to write negative. Why, sir? Why this negative? So my dear student, try to understand and bear in mind this particular concept, how you have to write this negative terminal, positive terminal, and what will be the sign over here. A number of students, okay, this is very confusing. Number of students, even they pass the standard 12 and they don't understand how we have to write the positive or negative, and that's why they are very weak to solve numerical questions. So try to understand over here. Suppose we are having a capacitor. Okay, this is the capacitor and this is the battery. This is positive terminal and this is negative terminal of the battery. This is capacitor. If charge is moving in this direction, remember, it is not necessary that charge will move always in this direction from the positive terminal. If there is another battery in the same circuit, it might be the charge is going or coming from this way also. Okay, but if you are moving and in any circuit, but remember, in one branch there must be only one direction of charge. Okay, it is not necessary that charge is coming from this way also and going from this way also. It is not possible. So if charge is going this direction and you yourself, okay, doing observation in the same direction, in the direction of charge, this is yourself, you are going in this direction. If you are going this direction, in the direction of charge, then you have to write in this way. You can start from here or from the capacitor. You have to write the potential. You don't require to write the plus or minus of the capacitor. Remember, in books that is given plus or minus, that is very confusing. Okay, so simply write the potential. And what is the potential? Q by C. Q by C. Okay. Now, if you are going in the same direction of the charge, then you have to write the potential positive on the capacitor. But if you are going in this direction and charge is coming from this direction, then you have to write negative. That is negative voltage on the capacitor. Remember, if you are moving with the charge, then you will write the positive, and if you are moving with the charge, then the first terminal of the battery you will use as polarity minus V, and nothing in this circuit remain, so it is 0. Now I am going to compare this one for your simplicity. Look at here, we have travel in this way and charge is going in this direction only. That's why you have been written positive. This one is the positive. Okay, and from here we meet negative terminal first. That's why you have been written negative equals to 0. Okay, look at here again. Another. Okay, another example. If this is capacitor, because this is very important, that's why I'm telling you again and again this concept. This is the negative terminal. Okay, my dear student, this is the negative terminal. Now charge is going in this direction and you yourself moving in this direction. You are observer and again you are moving in this direction. Now the capacitance, how you will write the equation? So the potential over this one will be how much? You are going in this direction. Okay, you are going in this direction. First you meet with the battery and then capacitor. We are writing voltage on capacitor. What is it? So the voltage will be minus. Why? We are moving opposite to the direction of charge. Minus Q by C. But you are moving and you meet first with the positive terminal of the battery. That's why it is positive. V is equals to 0. The battery voltage is V. This is the equation. Okay, so I hope you will be understanding how you have to write the terminal. Okay, I'm taking another example to explain this particular concept with the two capacitor. Okay, it might be in circuit you will find multiple battery even also. Okay, okay, now here another example I'm taking the two capacitor C1 C2 and the battery. Okay, my dear student, charge will flow in this one. Remember, the direction of charge you have to represent by the battery which has the highest potential. Since here only one battery, so this will be the direction of charge from positive to negative. Suppose it is Q. It is only one loop, so one charge will be there, and the voltage of this battery, suppose it is V. Now it is time to write the equation. If you can write the equation, write by yourself. Now look at here. If you have been written, very good, excellent. Now from point A, if you are moving, you can write this closed circuit as the A, B, C, D. Okay, in loop A, B, C, D, A. Okay, in this way you have to write the equation. In loop A, B, C, D, A. You are moving from this point. You meet first negative terminal of the battery minus V. Why? We are going in the direction of or with the flow of charge. So first meet with the negative minus, again from here plus, because we are going with the charge, Q by C1. How much charge reached at this capacitor? Q. How much charge reached at this capacitor? Again Q, because these two are in series. So plus. Why plus? Because we are moving with the flow of charge. So it is Q by C2. And again we reach to the same point. So it will equals to 0. And this is the equation. You can simplify now this one. I hope, student, you understand how you have to write the equation while using the Kirchhoff's voltage law. Okay, my dear student. Now we will solve few questions. This question I'm taking from NCERT. NCERT. Okay. One question of NCERT will be solved and you will understand the concept. There are a number of ways you can solve this question. Few methods are very easy. And here the battery is given. Battery positive terminal and negative terminal. Okay. This is, suppose C, this is also C, this is 2C and this is 2C. In NCERT it is given 300 volt and this C is 100 picofarad. It is given. Okay, the space was very small, that's why I've been written here the C and okay. Now how we have to solve this question? We have to vary. Since a student, I'm solving this question. First you have to distribute the charge. Remember, distribution of charge. Distribution of charge. Student, while you are studying on YouTube channel this video, you must repeat whatever I used to ask while the lecture. You must repeat if you are having the answer. Okay, that will strengthen your memory of this particular concept. This will last long in your memory. Okay, now distribution of charge. So we are going to distribute the charge. Since there is only one battery, start distributing. Q charge start flowing from this point Q. As this charge will reach to this point, the charge Q will reach to this point. There will be two branches, the two directions charge can move. Suppose one charge move Q1 in this direction, then what will be the amount of charge goes in this direction? The charge will goes, if it was Q and Q1 goes in this direction, it means Q minus Q1. Okay, Q minus Q1 will go in this direction. Now look at here, Q1 is coming, Q1 is coming, this is Q1, Q1 is coming. If charge is coming from this direction, remember this Q minus Q1 will not go this direction. I told you, in one branch there will be only one direction of charge. If charge is coming, it means you have to move, and from here the charge is coming, so this Q1 will not go in this direction. It means these two charge, this Q1 and this Q minus Q1, will be sum up and will go in this direction. Now how much charge it will go? Q minus Q1 plus Q1 will be the Q1 cancel out. You can see the battery left how much charge? Q. And battery again getting how much charge? Q. It means this particular circuit is based on the conservation of charge, which is correct. If any circuit is not based on the conservation of charge, it means that circuit has some problem. Okay, it is based on conservation of charge. Now my dear students, we are solving. How many loops you can consider here? The one loop, this one, and this will be loop 2. Two loop. In loop 1 we are going to write down in loop 1, despite of writing instead of writing A B C D this that, you can write directly the loop 1 and loop 2. Okay, and that clockwise anti-clockwise give you the direction. In loop 1 we are writing the equation. Okay, what will be the equation? From this point we are moving in the direction of charge we are going, that's why the equation will be Q1 by C. Okay, now look at here this will be minus. Why? Because we are going opposite to the flow of charge. Charge is coming from this direction and we are going in this direction, that's why it will be Q minus Q1 divided by how much? 2C. Okay, now go to this one again, minus Q1 by 2C equals to how much? 0. You can solve this one. It is as the 2C will be LCM, so this will be the 2Q1 minus Q minus Q1 minus Q minus Q1, it equals to 0. The LCM goes with 0, it will be 0. So it is 2Q minus, the 2Q1, Q1 and Q1, how much? 2, 3, 4. 4Q1 minus Q and minus Q. So the minus 2Q is equals to 0. You can simplify this as thus 4Q1 is equals to 2Q. It means Q is equals to 2Q1. Okay, the one relation. Now the next relation you will find from the second loop. So in loop 2, my dear students, we are writing the equation in loop 2. Start moving from any point. Okay, we are moving from this point. So first we meet with the battery. If we are moving from this point, we meet with the battery, and the negative terminal of the battery we meet here, the minus V, that is minus 300. Okay, now move to the capacitor. So this is the capacitor, and we meet the capacitor plus 2C. Sorry, at the voltage it is Q by C. Here the Q is how much? Q minus Q1 by C. Sorry, 2C, na? And again we made with the capacitor, again the plus, we are moving along with the charge, Q minus Q1 divided by again 2C, and then we are having another capacitor plus Q by C is equals to how much? 0. Now simplify this equation, and this will be the another equation for U. How much it is? 300. It is equals to, LCM will be again 2C. So it is Q minus Q1 here again and here also. So multiply by 2. This 2 has been solved already, plus the 2Q. Okay, 2Q. Taking this common, this 2 will be cancel out. So you can write it as 300 times C was how much? 100 picofarad is equals to this Q and Q, 2Q minus Q1. You can simplify this equation by putting the value of Q1 or Q over here, then you will have one variable. You have calculated here the Q. But what was the question? The question was, in this particular circuit, you have to find charge on each capacitor. Listen carefully. You have to find charge on each capacitor and potential across each capacitor. In this question, you have to find. I hope you have written this particular. I am rubbing this section. If you have to find charge on each capacitor, you can see carefully while calculating. If you calculated value of Q and Q1, then charge on this capacitor will be how much? It is Q. Which is the answer you got. Now the charge on this capacitor will be how much? Q minus Q1. Charge on this capacitor again Q minus Q1. Charge on this capacitor again Q. So in this way you have calculated the charge on each capacitor individually. Okay, and this is the very simple. Once you will be trained, you will just enjoy to solve this type of question. Now you have to find the potential across each capacitor. So the potential across each capacitor, what will the potential? As you have been calculated the capacitance, you are having the charge also. Capacitance given, but you haven't calculated the charge over here. So the potential will be Q by C. Already you have calculated the potential. You can find out the potential across each capacitor. If you will add sum up all the potentials, you will find the net potential of this particular branch will be how much? It is 300 volt. Okay, student. So in this way you can solve questions, number of questions, my dear student. I'm discussing here, my student, another way to distribute the charge, and then I'll give you some homework. Okay, look at here. Suppose this is the circuit. Right now we have written a circuit. In this way I am writing another simple circuit. These are the capacitors. Suppose Q, C1, C2, C3, and this is the battery of voltage V. Okay, this is the positive and negative terminal. Charge start flowing from this one. Okay, charge start flowing from this one. As you move with the charge, you will find the two direction over here. It means you have to distribute the charge. If you have distributed the charge as Q1 and Q2, this is also correct, remember. But this will give you the variable, two variables here, the three variables, Q, Q1, Q2. But no worry, my dear student, since this Q has been broken in two parts, then you can write the Q is equals to Q1 plus Q2. Okay, and the rest thing will be similar. How? In the same way as another method, in the same way as we have been study to distribute the charge. Those students are not getting, kindly see carefully. Again I am distributing the charge. Suppose C1, C2, C3, battery B, positive and negative terminal. Remember, from positive terminal charge start moving. So Q, at this point the two paths this charge will find, then it will break itself. Suppose Q1 goes in this direction and the total charge was Q, then how much charge will go in this direction? Of course Q minus Q1. To this capacitor, how much charge reach? Q minus Q1. To this capacitor, how much charge reach? Q minus Q1. In this way, in such a way, in same way, this capacitor will collect how much charge? Q1. And how much charge will reach to this capacitor? Again, Q1. Okay. So in this two way, you can distribute the charge and you can solve the problem. Okay, my dear students. One homework I'm giving you. This is your home assignment. Two homework I'll give. One. I'm arranging over here. One capacitor over here and battery. Okay, battery I'm placing over here. This is the positive and negative terminal. Okay, this is 50. This is 25. This is 50, and this is also 50 what? Microfarad. This all are in microfarad. Okay, and suppose this is 100 volt. You have to find charge on each capacitor, potential across each capacitor. This is the first homework, my dear student. This is your first homework. Now the second one. Little bit, okay, little bit change I'm giving you in this particular home assignment. Okay, 3 loop. I'm arranging here the 3 loops. Okay, capacitor, capacitor, capacitor. This is also the capacitor, 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 okay, battery. This is the battery. This is positive terminal and this is negative terminal. Now I'm giving you the values. Suppose it is 20 microfarad. I'm not writing the microfarad. You can understand. 10 microfarad. Suppose it is here we have studied for the one battery. Now let the 2 battery in this question. Okay, and this is suppose 20 microfarad. Yes, 20, 10. Here the 100 volt. Here suppose it is 200 volt. The 100 volt. Okay. Oh, this one also. Let 10 microfarad. You have to find capacitance, sorry, charge on each capacitor and voltage across each capacitor. Okay, student. So these 2 are your home assignment. Okay, my dear students. Thank you very much.